We are told figure 2 shows a sketch of part of the curve C with equation y equals x ln x. Okay, so let's pick that out. The line L is the normal to C at the point P, which has coordinates EE. So line L is a normal to C, and then at this point. The region R, shown, shaded in figure 2, is bounded by the curve C, the line L, and the x-axis. And we have been asked to show that the exact area of R is AE squared plus B, where A and B are rational numbers to be found. And this question is worth 10 marks. The first thing I'm going to do is I'm going to annotate figure 2 by drawing a vertical line from point P to our x-axis. The reason I've done this is because now we've split our area, our shaded region R, into two smaller shaded regions, R1 and R2. R1 is the area underneath the curve, so underneath curve C, okay? And R2 is this right angle triangle, which is going to make finding it easier, the area much simpler, okay? The other point I'm going to pick out on is because we have drawn a vertical line down, it means the point at which these two regions intersect is E, okay, like that. So, what we need to do now is we need to find the equation of line L, okay? So, what we say, finding equation of line L, like this, okay? So, the way we're going to do this first is we're going to use the fact that L is a normal to C to find the gradient of L. So, what we're going to say is, since line L is a normal to C at P, this means that our gradient of line L at P equals minus 1 over our gradient of the tangent to C at point P, okay? And in doing so, I'm actually just going to write that down, all right? So I'm going to write that ML, which is the gradient of the line, this is the gradient of L at P. So gradient of L at P. And MT equals gradient of tangent to C at P. Okay? The only part we can find right now is MT. So what we will say is that we will look for MT. Now, MT, being the gradient of the tangent to C at P, this is going to be dy by dx at x equals A. So the gradient, dy by dx, of the tangent to C, which is dy by dx, at x equals A, which is at point P. Okay, so that's how that works. So now we will say dy by dx equals d by dx of x ln x, like that, okay? Because that is the equation of our curve C. To find this, what we need to do is we need to use a product rule. And the product rule says that dy by dx will be the first function times the derivative of the second function plus the second function times the derivative of the first function. So it will be x times d by dx of ln x plus ln x times d by dx of x. This equals the derivative of ln x with respect to x is 1 over x. So we have x times 1 over x, which is 1. And then the derivative of x with respect to x is 1. So we have plus ln x, like that. Okay? What we then say is this means that mt equals dy by dx at x equals a. So it equals 1 plus ln of a, which is 1 plus 1, which equals 2. Okay, so we can just say mt equals 2. Now we can say, because ml equals minus 1 over mt, that it equals minus a half. And then from here, we can use the fact, so we say using y minus y1 equals the gradient of L times x minus x1 to find L, okay? And we know that y1 equals A and x1 equals E, because we've been told this in the question. This is the point P, okay? So I'm just going to write in brackets point P. From here, what we will say is that y minus A equals minus a half, which is our gradient of L, times x minus A, like that. Coming down to the next page, we can rearrange this to say that y equals e minus half x plus half e. From here, what we can actually do is we can rearrange these and sum these. So we can say that, therefore, y equals minus half x plus 3 over 2e. Okay, so I'm going to come back to our diagram and add this. So we're going to say that y equals minus half x plus 3 over 2e, like that. Now we found L and we know our equation of C. What we can actually do is we can look and start solving the question. So to find the area under the curve, we actually need to know the x-coordinate where our curves intersect the x-axis, okay? So we're going to start by finding L because we're already working with it. And what I'm going to say is that because at the x-axis, y equals 0, we're going to solve when minus a half x plus 3 over 2a equals 0 to get this point here, okay? So, what I'm going to say is, finding where L intersects x-axis. Okay? So, to do this, we're going to use the fact, like as we said, that at x-axis, y equals 0. And then we're going to come with that minus half x plus 3 over 2e equals 0. This means that half x equals 3 over 2e. And this means that x equals 3e. Okay? So that's the point, that's the x-coordinate of where the line L intersects the x-axis, which is 3e, like that. The final step is to find where curve C intersects the x-axis. Okay? So what we're going to say is finding where C intersects x-axis. And then again, because at x-axis y equals 0, we can say that ln x equals 0. From here, we have two solutions. We can say x equals 0 or ln x equals 0, and for ln x to equal 0, this needs to, what this means is that x has to equal 1, okay? So we say that this implies x equals 1, all right? Coming back to our diagram again, we're going to draw on our final two solutions. So we have 0 and 1 here, okay? Now we can actually start finding the area. So the first thing I'm going to do is I'm going to find the area of R1 because that comes before R2, okay? R1 is the area under the curve C, okay, between, so C, the x-axis, and this vertical line here, okay? So we're going to be integrating curve C between 1 and A, all right? So what we're going to write is we're going to say area R1 equals the integral from 1 to a, so of our curve C, which is x ln x with respect to x. To integrate x ln x, we need to use integration by parts. And integration by parts tells us that if we have the integral of u dv by dx with respect to x, this equals uv minus the integral of v du by dx, like that, okay? And then, sorry, with respect to x at the end. So what we need to do now is we need to pick a u and we need to pick a dv by dx, okay? The common rule here to picking u and dv by dx is you pick for u whichever would be hardest to integrate, okay? So let's look, integrating x, well, that's easy, that's x squared over 2. But integrating ln x, well, to do that, you'd have to go into a second instance of integration by parts. So because ln x is the hardest to integrate, you would pick it for u to differentiate. So u equals ln x, and that leaves dv by dx equals x. This means du by dx equals 1 over x, and that v equals x squared over 2. Now, what we are going to do is we are going to apply our formula here. So what we will say is that this equals, so uv is x squared over 2 ln x, like that. I've actually done VU, but it's neater to write it this way, and it's the way the Marxium has laid it out, which is why I've copied that, okay? Again, from using our limits, e to 1, minus the integral from 1 to a. So it is going to be v du by dx. So v is x squared over 2, and then du by dx is 1 over x. So it's going to be x squared over 2 times 1 over x with respect to x, like that, okay? Next step, x squared over 2 ln x. Using our limits of integration. And then this is going to be minus, now x squared over 2 times 1 over x is the same as x over 2. So all we're doing is integrating x over 2. So the integral of x over 2 with respect to x is x squared over 4. So this is going to be minus x squared, let's just make that a bit neater, x squared over 4 from e to 1, like that, okay? So all we need to do now is plug in e and 1 for each of our parts and then simplify it, okay? So what we'll end up with is that this equals e squared over 2 ln a, okay, minus e squared over, 1 squared over 2 ln of 1, close our brackets, minus, now open our brackets again, e squared over 4, minus 1 squared over 4, okay? Like that. So from here, what we can do now is we can start evaluating stuff. So e squared over 2 times ln e. Well, ln e is just 1, okay? So this is just going to be e squared over 2. Now, ln 1 in this part here, ln 1 is 0, okay? So this is 0. And this means that this entire term becomes 0 and cancels out, okay? So what we're left with is e squared over 2, and then we've got a minus e squared over 4, and then we have plus 1 over 4, like that, okay? E squared over 2 is the same as 2e squared over 4, so 2e squared over 4 minus e squared over 4 is e squared over 4 plus 1 over 4, like that, okay? So now we have found the area R1. The next step is to find the area of R2 equals. Coming back to our diagram, area R2 is a right angle triangle, okay? Now the base is between E and 3A, okay? So the base will be 3E minus A, and our height will be A, okay? Because look here, how we've been told that this point, I'm just going to draw it now, here, okay? This point here is in fact A as well. So it's a height of A and it's a base of 2A, okay? So we're going to say that the area equals half times 3A minus A, which is our base, times A, which is our height. This gets us half times 2A times A, which equals A squared, like that, okay? Final step is to say that area R equals R1 plus R2. We said that R1, if we come back, was e squared over 4 plus 1 over 4. So this is e squared over 4 plus 1 over 4. And R2 is just e squared, like this. So what we now have is we have e squared over 4 plus 1 over 4 plus 4e squared over 4. And this means that we get 5e squared over 4 plus 1 over 4, like that. And here I'll just add that A equals 5 over 4 and B equals 1 over 4, like that, okay? Because they did say A and B are rational numbers to be found. So we found them and we've shown them explicitly. So this question is worth 10 marks. Your first 2 marks come from getting that dy by dx equals 1 plus ln x. Your third mark comes from using the information to get the equation for L and to show some attempt of solving for x when y equals 0. Your Fourth mark comes from getting that x equals 3e when L meets the x-axis. Your fifth mark comes from either attempting to solve the integral or the area of the triangle for the shaded region. Your sixth mark comes from doing integration by parts to solve x ln x to get this line. Your seventh and eighth mark comes from correctly evaluating that to get half x squared ln x minus a quarter x squared. Your ninth mark comes from finding your other area and correctly getting the area R1 and R2 and knowing that the final area is the sum of those, and your 10th mark comes from getting the correct final area of 5/4 e squared plus 1/4.